Hey guys, this video is about the ideal gas law. The ideal gas law is the fifth gas law, okay? Um, and it's a very important one and it works really well and it's very easy to use. Okay, now we've worked so far with pressure, volume, and temperature through the combined gas law, the Charles law, and the Boyle's law. Then we talked about the combined gas law with all three of them put together. Now, what if we wanted to solve for, say, grams of a gas or moles of a gas? What do we do? Well, we're going to need the ideal gas law. The ideal gas law is the gas law that includes all four variables, P, V, T, and N for moles. And remember, you can go from moles to grams easily using the mole map. Now, let's look at the modification of law number 4, the combined gas law. Okay, now just remember the combined gas law is P times V over T set equal to itself, and those are the second variables. Okay, now first you must recognize that the volume occupied of a gas at a given temperature and pressure depends on the number of particles present. Therefore, moles must be proportional to volume. Okay, so moles and volume are proportional. So as you increase the number of moles, all right, you increase the volume. Now, additionally, we know that the volume is inversely related to pressure and volume is also proportional to temperature. That's an important fact. But we're going to look at this one specifically. Volume is proportional to N. Now you can introduce moles, which is the little n, to the combined gas law. So here's the combined gas law with N next to it. So we're adding the number of moles to it. Now let's talk about the gas law constant, which is known as the letter R. Okay, the gas law constant. Now, this equation shows us that P times V divided by T times N is a constant. All right, so this part of the equation of the combined gas law with the moles added to it is a constant. Therefore, P times V divided by T times N equals R. Now, if you know the value for pressure, volume, and temperature and the number of moles for one set of conditions, you can calculate a value for the constant R. And we will do that using these variables here. Now recall that 1 mole of every gas occupies 22.4 liters at STP. And STP has a pressure of 101.3 kilopascals and 273 kelvins. You then can plug these variables into this equation here. R equals P times V over T times N. This results into the following. R equals 101.3 kilopascals times 22.4 liters divided by 273 kelvins times 1 mole. Okay. You multiply the numbers in the numerator, divide it by the numbers in the denominator, and you get 8.31, okay, liters times kilopascals over kelvins times mole. Now, this is the gas law constant dealing with kilopascals. There are 3 other R values based on atmospheres, millimeters of mercury, and torrs. Okay, but we're not going to use them. If we do use them, I'll give you those values. Okay. Now this is cool, deriving ideal gas law equation. So basically we have this right here. Pressure times volume over temperature times moles set equal to R. So let's rewrite this equation into a nicer usable form. So what we're going to do is multiply both sides by N. Okay. And we get P times V over T set equal to R times N. Then we multiply both sides by T. Okay. And we get the final equation, PV equals nRT. Okay, I just flip these around. It makes it look nicer. Okay, so PV equals nRT is the ideal gas law equation, which is very simple to use. So if you're given, let's say, pressure, volume, temperature, you can find moles because the gas constant is 8.31, which is found up here. So you have to use these variables here, and you'll cancel out the variables that are in that gas law constant, okay, leaving you with the variable of choice. Okay, so when you're looking to find the number of moles, you're going to use this equation and solve for n and rewrite this equation, which we'll look at in the future. All right, guys. So that's the end of this video.